mateys. Today we be talking about evaporation. I'm chewing on my butterscotch rum flavored lollipop. Because where is the rum when you always need it, right? Alright, all kidding aside. Let's talk about evaporation. On Tuesday, we will have discussed evaporation and intermolecular attractions. Intermolecular means attractions between molecules, not between particles within the molecule, not a bond, but an attraction between the particles. Now, our beginning question is, how do intermolecular forces affect the evaporation of a liquid? And also, how does the mass of a molecule? So we'll be testing two different things. All right, so you'll have a setup with test tubes. I'll have a test tube rack out and test tubes, and you will have probes, temperature probes, hooked up to the lab quests. And this is what we'll be using for the lab. I can actually talk. First thing you need to do is the pre-lab. You need to draw the structural formulas for each of these substances. Calculate the molar mass and identify if there's any hydrogen bonding. So first make a data table in your lab notebook and title the first column substance, the second column formula, the third column structural formula, the fourth column molecular weight, and the fifth column, hydrogen bonds. Yes or no. Okay, I'm going to pause for a moment, or you guys pause to draw this out, the boxes out. All right, so let's draw our structural formulas. The first one, we've got 2 carbons. The 2 carbons are going to go in the middle. We know each carbon can have 4 bonds, 2 electrons in each bond. We can tell, since it says CH3, that the first carbon is bonded to 3 hydrogens. The second carbon is bonded to 2 hydrogens, and the last the last bond taken up on that is an oxygen bonded to 1 carbon and 1 hydrogen. This is an alcohol. In fact, the first 4 are alcohols. That's why they all end in OL. You guys can calculate your own molecular weight. The second one, we've got a chain, and I've left one out. And I've already sent these to print. Great. It should be CH3, CH2, CH2OH, because we have 3 carbons. The first carbon is bonded to 3 hydrogens. The second is bonded to 2 hydrogens. The third is bonded to 2 hydrogens. And then an O and then an H. This is propanol. Propyl means 3. Butanol, we've got 1, 2, 3, 4 carbons, so we've got that at least drawn or written correctly there. CH3, CH2, 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 OH. All right, hang on. All right, for the methanol, I'm going to erase these just because they're going to get in my way. Methanol is very simple to draw. We have a carbon bonded to 3 hydrogens and an OH. Pentane, we're going to have a chain of 5, only this time, and once again, I've written something out and I didn't proofread it, we're not going to have an OH on the end. So we've got 1, 2, 3, 4, 5 carbons. Carbon is bonded to 1, 2, 3 hydrogens, then 2 hydrogens, CH2, 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 and then finally CH3. You guys can calculate the molecular mass. Last one is hexane. Again, Bad mistakes on my part. I guess I'm going to rewrite all those or write them all onto the sheets before I pass them out to you tomorrow. Hexane is CH3, CH2. We've got 6 carbons this time now. CH2, 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 and finally 1, 2, 3, 4, 5. Our 6th one is CH3 again. All right. For our procedure, step 1, you need to obtain and wear goggles. And I don't have a set of goggles on the desk, so just pretend like I put them on. Step 2, on the meter scale. So you're going to get your LabQuest out. The meter scale is when you have the picture open that has the red area on it. Tap length. So you've got, all right, your instructions say tap length, but it's not length, it says duration. And it is the 3rd box down. The first one is mode. The second one I think is samples per second. And then duration. You're going to click duration and you're going to change your time to 60 seconds. And then hit OK. Step 3. You've got 2 probes. You're going to wrap them with a little bit of filter paper. Okay, and this happens to be one left over from last year. So what we did, we had the filter paper that I cut out of a coffee filter, and they're approximately all the same size. And I've got little orange rubber bands, and you'll just wrap those rubber bands around the end of the piece of paper on there. Okay, so you'll have paper that you'll wrap around the end of the probe. Let's draw that then. So here's our probe. And we're going to take paper and wrap it around. Does that kind of look like paper maybe? And then you'll use a little rubber band to secure it. So in the end, it's going to look like this. Okay, you have 2 of them. Okay, make sure the containers sorry, getting ahead of myself. Step 3, step 4, stand the probe in the ethanol container. So you're going to have a test tube rack, and you're going to put one probe into the one that says ethanol, and one probe into the one that says propanol. After the probes have been in there for 30 seconds, hit start. And we know that's the little green arrow. Monitor the temperature for 5 seconds, and then pull both probes out, and you're going to tape them to the edge of the table. And so I've got some tape here. Get this where you can see it. There we go. I'm going to take my probe and I'm going to tape it. It's going to be hooked to the LabQuest, and I'm going to tape them down. So one person, they've already started the timer. One person's going to be ready with the tape. The other person's going to have the probes, or maybe 2 people have the probes. And you'll lie them down, and the whole time it's collecting data. And you want to have them so they're hanging off the edge so that they can start to evaporate. And you guys do not want to be doing any of this stuff. No, you can't even see me. None of this waving stuff, okay? It'll work. Did you guys even see me do that? I couldn't tell. There's the probes, there's the tape. Hopefully you got that idea now. All right. So here's the edge of the table. We're taking one probe and another one right next to it with our little paper on the end, and we're going to take a piece of tape and tape them down. Okay, I appear to have run out of room, so I'm going to start a new page. Step 6, data collection will stop after 1 minute. And it'll stop automatically, so you do not have to hit the little red button. Examine the graph of the temperature versus time. So you've got a graph. Based on your data, determine the maximum and minimum temperature. So you're going to have had a temperature, and you're going to find a max and a minimum and record. And you're going to need to record that into a data table that looks like this. All right, so hit pause and go ahead and copy that down. You're going to put the data into that data table. Then for step 7, you'll subtract the minimum from the max and record it back in that data table you just wrote. And then for step 8, you will repeat steps 3 through 7 with butanol with probe 1 and pentane for probe 2. And then step 9, you'll repeat again for methanol and hexane, probe 1 and probe 2. And there you go. That's what you need to get done. So you need to have two data tables, one with the structural formulas and the molecular mass and whether there's hydrogen bonds or not, and the second one with your temperature, your max temperature, your minimum temperature, and your temperature difference. Thank you for playing with me today.